my last lecture, I have discussed Kirchhoff's circuit laws and their applications. In this lecture, I will discuss superposition theorem and supermesh technique. Superposition theorem states that in a linear bilateral circuit having more than one independent sources, voltage or current in a branch is the algebraic sum of voltages or currents due to each independent source when other sources are replaced by their impedances. Voltage source is replaced by making the branch short. On the contrary, current source is replaced by making the branch open. Let me explain the matter. Here we have considered a circuit having two voltage sources V1 and V2. Three resistors have been shown here and their corresponding branch currents also given there. Okay, so according to superposition theorem, we should consider individual independent sources. So V1, V2 are independent sources. So first, whenever we consider V1, then V2 will be eliminated and that will be replaced by making the circuit short. So this circuit is the corresponding circuit. Now as V1 is acting, therefore current directions are also changed because only V1 is the supplying voltage which will supply current to the entire network. Whenever we will consider V2, at that time this circuit should be considered, and now according to V2 the current's directions are also changed. So now total current I in the branch related to R1 resistor is equal to I1 dash minus I1 double dash, okay, or we can say that I1 dash plus of minus I1 double dash, because original current I1 is having this direction and I1 dash is maintaining the original directions. That's why I1 dash should be considered as positive, but I1 double dash is just opposite to original direction. That's why I1 double dash will be considered as negative. Okay, thus I1 equal to I1 dash minus I1 double dash. Similarly, I2 is equal to I2 double dash minus I2 dash, because I2 double dash is maintaining the similar direction of original I2, whereas I2 dash is not maintaining this direction, rather it is just opposite to I2. Okay, so thus I2 equal to I2 double dash minus I2 dash. Now I3 is equal to I3 dash plus I3 double dash, because both the currents I3 dash and I3 double dash are maintaining the actual directions of I3. That's why I3 equal to I3 dash plus I3 double dash. So in this manner, individual branch currents will be determined. That is the superposition theorem. Here we have considered an example where you have to find out the power supplied by the voltage source. Let's consider I current B supplied by the voltage source. Now by applying superposition theorem and considering only 1 ampere current source, 2 ampere current source is replaced by making the circuit open, whereas 10 volt source is replaced by making the branch short. Let's consider the current flowing through the branch having 10 volt source be I dash. Now by applying current divider rule at this node, we can get the value of I dash, which is 0.5 ampere. As I dash is flowing just opposite to the I, that's why I dash will be considered as negative. So I dash is equal to minus 0.5 ampere. Similarly, when we consider 2 ampere current source, then this is the corresponding circuit. as the right hand part of the circuit is short circuited, that's why entire 2 ampere current will flow through this short circuit branch. Thus I double dash is equal to 2 ampere. Again, as I double dash is just opposite to I, that's why that I double dash will be considered as negative. So I double dash equal to minus 2 ampere. When we consider 10 volt source, at that time this is the corresponding circuit. Now by applying KVL, we can get the value of I triple dash. Here I triple dash is just in the same direction with the I. That's why I triple dash is considered as positive. Now total current I is the sum of all the three currents I dash, I double dash and I triple dash. Thus I equal to 0. Therefore power VI is also 0. Circuit problems related to the circuits having multiple energy sources can be solved out by using superposition theorem. Already we have seen that. But sometimes the use of super mesh technique is more beneficial than that of applying superposition theorem. Now I will discuss the matter. Actually, super mesh technique is preferable whenever a circuit is having number of current sources. Okay, because if a circuit is having multiple current sources, at that time, although that circuit problems can be solved out by using superposition theorem, no doubt, but it is very much time consuming. On the contrary, if you prefer or if you apply the super mesh technique, then it will take minimum time. I have considered here a circuit having multiple current sources. So here this current source is common for this adjacent two loops. At that time we can eliminate that current source by making this side open. At that time these adjacent loops will be converted into a single loop. That is the super mesh. So the mandatory condition is that current source must be common for adjacent two loops. Then only you can eliminate that current source. In that case, one thing you should remember that although we can eliminate the current source, but we cannot ignore the effect of the current source. Before eliminating the current sources, you have to consider the effects of that current sources. With an example, I will explain the matter. There is an example, although we have considered this example in case of superposition theorem also. Still, similar problem we have considered here so that we can solve out the problem with the help of super mesh technique. Current at this node is 3 ampere. Here at this node 3 plus I ampere. Now 3 plus I ampere is flowing through this resistor. There also 3 plus I, as 1 ampere is entering, so 2 plus I is flowing through 1 ohm resistor, and there also 2 plus I. Again 2 ampere is entering current, that's why rest of the current I flows through the battery terminal. Now all the current's effects have been considered and the current sources have been eliminated, because these two current sources are common sources for their associated adjacent loops. Now by applying KVL, we can find current I equal to 0 ampere. Thus, power equal to 0. Thus, we have seen that the circuit problems related with that particular circuit having multiple current sources can be solved out by using super mesh technique instead of using superposition theorem with minimum time period. Actually, this problem has been appeared in GATE 2010 and only 1 mark has been allotted for this. That's why you need to very much careful about your time. So same problem you can solve out by using superposition also, but using this super mesh technique within very short time period you can solve out this problem.